Hello students, today's question is this one. It is a good example of binomial distribution. The given information in the question is an airport limousine can accommodate only 4 passengers on one trip. But for these 4 passengers, company accepts 6 reservations. And from the previous records, company says that 15% of those making reservation do not appear for the trip, right? So first part is, in the first part, we need to find out the probability that at least one individual with reservation cannot be accommodated on the trip, right? Let's get started. Design a random variable y that shows the number of customers appear for the trip out of 6 reservations. As it is given in the question that 15% of those making reservation do not appear for the trip. So, by the complement rule of the probability that a customer will appear for the trip is 1 minus 0.15 is equal to 0.85. Here y has binomial distribution with parameters n is equal to 6 and probability of success, that is p is equal to 0.85. Now the question arises, y is binomial distribution. The reason behind this is the number of trials for each trip is fixed to 6. The probability of success for each trial, that is for each reservation, is fixed to 0.85 and each reservation is independent to other. Today, all the condition of binomial distribution has been satisfied. So y has a binomial distribution. Now, since we need to find out the probability that at least one person cannot be accommodated for the trip, this will happen when number of customers who appear for the trip is more than 4. That is, if 5 persons or 6 persons out of 6 reservations appear for the trip. So we need to find out the probability that out of 6 reservations, 5 or 6 persons appear for the trip. That is, y must be greater than equal to 5. In that case, at least one person will not be accommodated on the trip, right? So this is the PDF of binomial distribution. 6c by y shows the number of success out of 6. Probability p power y, 0.85 p power y, 1 minus 0.85 p power 6 minus 1. When we calculate, it comes to 0.776. This is the probability that at least one individual with a reservation cannot be accommodated on the trip is 0.776. We can calculate it with the help of Excel function. The required Excel function to calculate this is 1 minus binom dist. The parameter of this function is 4, means the number of successes we require, 6 the number of trials, d the probability of success per trial, and that this parameter is true or false. This can be true or false. The here first question arises, why we do 1 minus. The reason is binomial distribution gives us the probability that y is less than or equal to 4. But here we need to find out the probability that y is greater than or equal to 5. Y is greater than or equal to 5. Using the complement rule of probability, it is equal to 1 minus probability y is less than or equal to 4. Right? So the probability y is less than or equal to 4 is given by this function, and 1 minus means it will provide us probability y is greater than or equal to 5. Now the second question arises, why it is true or false. find out the probability that y is less than or equal to 4. So this parameter is true. We need to find exact probability instead of cumulative probability. Then this parameter will be false. Right? So now comes to second part. If 6 reservations are made, what is the expected number of available places when limousine departs? This is our second part. Here, find a new random variable m that shows the number of seats available in the limousine when it departs. Right? It is given in the question that there are only 4 seats in the limousine. So, number of seats that can be available when limousine depart is 0, 1, 2, 3 or 4. 0 means all the 4 passengers all the 4 seats are occupied. 1 means 3 seats are occupied and 1 is empty. 2 means 2 seats are occupied and 2 are empty, and so on. So let us calculate the probability when m is equal to 0. M is equal to 0 means the number of seats available is 0. That is 4 or more customers appear for the trip out of 6. Since company made 6 reservations for 4 seats, either 4 customers, 5 customers or 6 customers appear for the trip. Right? Here y is the same variable as we defined in part A. So here probability of m is equal to 0 means we need to find the probability y is greater than or equal to 4. That is y is equal to 4 or y is equal to 5 or y is equal to 6. Means probability of y greater than or equal to 4 is equal to probability of y is equal to 4 plus probability y is equal to 5 and plus probability y is equal to 6. Right? When we are applying binomial distribution, the probability of this is 0.9527. Now, the Excel function that can be used to find the above probability is 1 minus binom dist. Since we need probability greater than or equal to 4, so here we have to put number of successes is equal to 3, number of trials is probability of success per trial is 0.85 and true because we need cumulative probability. 1 minus using complement rule of probability like we did in part E. Right? Likewise, when m is equal to 1, number of seats available is 1, that is 3 customers out of 6 appear for the trip. So, here we need to find exact probability that y is equal to 3. So, this using binomial distribution PDF, the probability of this is 0.0415 and the Excel function that we can use to find this probability is binom dist 3, 6, 0.85 and false. Right? False because here we need to find exact probability, not cumulative probability. When m is equal to 2, that is number of seats available is 2 means 2 out of 6% appear for the trip. So this is 0.0055. When m is equal to 3, the number of seats available is 3, that is only 1 person out of 6 appear for the trip, plus 3 seats are empty when limousine departs. This is 0.004. And when m is equal to 4 means there is no customer in limousine, no person appear for the trip out of 6. So it is approximately 0.000. Summarizing these all probability into table, we have the following table. For m is equal to 0, the probability that there is no seats available in the limousine is 0.9527, like this one. But in question says we need to find out expected value of the number of seats available. To find out the expected value, we need to multiply m to its probability. So this column shows the same, right? And the sum of these values is 0.0537. So the expected number of seats available when limousine depart is 0.0537 or 0.054. Right? Now comes to part C, that is last part of the question. This part is little bit lengthy and tricky also. So listen carefully, right? The question says that the probability distribution of the number of reservations made is given in the accompanying table. In this part, the number of reservations can be 3, 4, 5 or 6. That is, company can make 3 reservations with probability 0.14, can make 4 reservations with probability 0.19, 5 reservations with probability 0.29 and 6 reservations with probability 0.38. We need to find out the number of passengers on the selected trip with this information, right? So, let's get started. X is equal to 0 means there is no customer on the trip, limousine is empty. So, let us define one more random variable k that shows the number of reservations made by the company. When 3 reservations are made by the company, then k will be equal to 3 and probability of k is equal to 3 is 0.14, right? So, if 3 reservations are made and x is equal to 0, it means out of 3 reservations, 0 customer appear for the trip. The customer appear for the probability that customer will appear for the trip is remains same for is equal to 0.85. But the number of trials becomes n is equal to 3 instead of n is equal to 6 in this case, right? So, here we need to find out the probability that the number of reservations made by the company is 3 and the trip is Z and no customer appear for the trip, right? Since the number of reservations made by the company and number of customer appeared for the trip are independent to each other, so this probability can be written as probability k is equal to 3 and x is equal to 0 can be written as k is equal to 3, probability x is equal to 0 using the multiplication rule of probability. So as we know, the probability of k is equal to 3 is 0.14 and using the PDF of binomial distribution, the probability x is equal to 0 is 0.0034. So when we multiply these, the result is 0.000476. Likewise, when 4 reservations are made, then probability of k is equal to 4 is 0.19 as given into the question. It's given into our question. So in that case, it means when x is equal to 0 means 0 customers out of 4 appear for the trip. So the required probability is using here the number of trials for binomial distribution becomes n is equal to 4. Probability of success remains same and k is equal to 4 given 0.19. So that this probability becomes this one 0.000095. Likewise, for 5 reservation, and 5 reservations are made means 0 customers out of 5 appear for the trip. So this probability is this one. Likewise, when 6 reservations are made, 0 customers out of 6 appear for the trip. So this one. Now we will make either 3 reservations, 4 reservations, 5 reservations or 6 reservations. It is not possible that at a time company make 3 reservations and also 4 reservations, right? So these events are mutually exclusive events. So using the law of total probability, the probability that no customer is on the trip is probability x is equal to 0 will be sum of these 4 probabilities that we calculated previously. So it is equal to 0.006, right? Now we start for finding x is equal to 1. It means there is only one customer out of 4 is in the limousine. 3 seats are empty. When 3 reservations, likewise, like we did for x is equal to 0, we need to find out probability for x is equal to 1. The probability that there is only one customer on the trip is probability x is equal to 1 becomes this one. Likewise, for x is equal to 2, we need to consider all the 4 cases. That there are 2 customers on the trip is this one. So the probability that there are 2 customers on the trip is this one. Now we need to find out x is equal to 3. It is same as we did for x is equal to 0, 1 and 2. Probability that there are 3 customers on the trip is, and the last case is finding x is equal to 4. Here we need to rule out that company made 3 reservations because in case there are only 3 reservations, it is not possible that there will be 4 customers on the trip. So we need to start with k is equal to 4 is equal to 0.19. Right? So in that case, 4 customers out of 4 appear for the trip. So the probability for that is this one. When 5 reservations are made, then if 4 or 5 customers out of 5 appear for the trip, then there will be 4 persons in limousine when trip started. So we need to find out the probability that x can be that number of persons appear for the trip can be 4 or 5. These are mutually exclusive events, so we need to add this probability and the probability becomes this one. Likewise, Likewise, when x is equal to 6, it means that number of person in a limousine will be 4 if either 4, 5 or 6 customers out of 6 appear for the trip. So we need to find out the probability that number of person appear for the trip can be 4, 5 or 6. 4, 5 or 6. So the required probability is this one. So the probability that there are 4 customers on the trip is this one. Summarizing all the results into a table, the required probability distribution of x is this one. Please write in the comment box if you have any query, and my students can do me a WhatsApp